Hello everyone, welcome back to my channel. My name is Piyush and this is video number 17 in the series CK 2024. And in this video, we'll be looking into autoscaling. We'll be looking into HPA, VPA, and so on. We'll be looking into overall concept of autoscaling. So although this topic is not important from exam perspective, from CK exam perspective, but if you are someone who is a beginner to Kubernetes or who is learning Kubernetes and want to do the deep dive into it, this is really important and I wouldn't suggest to miss this topic. So that is why I have included that in the series, even though it's not part of CK, but it is, a good to have, a must have topics to understand. So comments target for this video will be 150 comments and like target for this video will be 250 likes. I'm sure you can do that in next 24 hours. So without any further ado, let's start with the video. Okay, so let's begin with understanding what actually scaling is. Forget about auto scaling for now, forget about HPA VPA for now, but let's just start with what actually scaling is. So scaling is changing your servers or your workload to meet the demand, right? And it can be done manually or by automatically. So if you remember when we have discussed deployments, because we have looked into deployment in detail. So with deployment, it comes with replicas so that identical copies of a single pod can run in the same deployment to serve the customer, right? So it is to be done to scale the workload, right? So that's one of the example of scaling. Or when we are deploying our workload in multiple nodes, this is one example of scaling. So we are actually increasing our resources based on the demand by the customer. And because with the deployment, with the multiple nodes, it was done all manually, right? We specify how many replicas do we need, or we specify like if we need to scale it beyond that. So we update the deployment or replica set to a desired number of replicas. So it was all done manually till here. And if we see like if you are running your workload on a production system, or let's say even something, you won't be able to monitor it 24/7 and you won't be able to do it manually. Like consider an application with thousands of nodes, thousands of pods. How would you do it manually? It's almost impossible to do that manually, and it's not efficient, it's not recommendable. So there was a need of auto scaling, something that could do that automatically based on the demand, based on the increased workload, or based on the utilization of resources on the server. So that's when the auto scaling concept came in. So let's see what are different types and what exactly are these. So let's say you have a node. The first one, you have a node with one pod running, which requires one CPU and one memory at the time. And there is a constant load. Let's say this is a database, or even a public facing application, doesn't matter. So let's say there is some load getting generated on this application. And let me add the user over here as well. We have multiple users accessing this application. Doesn't matter how they are accessing it just like they are accessing this application. That's important for now. Okay, so users are accessing this application, and let's say user load increases. Instead of one user, now we have two user, three user, and it keeps on increasing. So our application would fail at some time. It will reach to its bottleneck. At some time it will stop responding to the user, or there'll be a lot of latency in responding to the request. In that case, we use a concept called horizontal pod autoscaling. I will explain it to you what exactly it is. So what it will do, this horizontal pod autoscaling, this will add identical pods in the deployment automatically based on the load on the server. And this load can be, increased CPU or increased memory. Let's say we set the target as whenever there is a load of at least 60% of the average CPU utilization, add one pod. And it keeps on doing that. And let's say if there are more users to the application, so it will add more replicas of that pod, and it will all be done automatically. So over here in this process, we are actually horizontally adding the pods, and it is done automatically. So that is why it's called horizontal pod autoscaling. So first the flow is horizontal, and then we are doing it automatically. So horizontal pod autoscaling, right? It's the self-explanatory term, but this is what I mean by that. Now let's say we have another node or another cluster and a separate project, okay, and a separate workload running. So again, over here as well, we have some users accessing this application, okay, and application load is getting increases, but this application can afford some downtime, or it can afford some restarts or some slowness. It's not mission critical, or it's not something which expect a lot of customer. It don't work on seasonal peak hours, and so there are different use cases, right? So in that case, what we can do is we can use a process called vertical autoscaling. So I'll explain it to you as well. So instead of horizontal pod autoscaling, they can use vertical pod autoscaling. So in that, what will happen is instead of this one pod, I mean the pod that is serving, it has one CPU and one memory. We can automatically resize this to a bigger pod, and now we resize the requirement, the resource requirement. Instead of one CPU, let's say we go with 10 CPUs and 10 GB of memory. So now, even if, and it all happens when there is an increased workload, so increased user traffic and so on, right? So now this pod will be replaced by a bigger pod. It will require a restart. So that's what I said. Like, it will happen only when your application can afford some downtime. So it is stateless in nature and it can afford some downtime. There is no mission critical workload running that cannot afford to go with the restart and so on, right? So this is what I mean by vertical pod autoscaling. Now, this is in terms of Kubernetes, but if we look at the concept of horizontal autoscaling and vertical autoscaling, it stays the same, right? In horizontal autoscaling, let's say instead of these pods, we have virtual machines. So if we take an example of a cloud, let's say AWS, in that we have an autoscaling group. In autoscaling group, we specify how many EC2 instances do we need. Let's say it starts with 1, and then we set the number of replicas or desired number to 3, and it will add more replicas when the CPU load increases on the server. So that's example of horizontal autoscaling. In vertical autoscaling, instead of pod, again we have an EC2 server, and we replace it with a bigger machine whenever there is an increased CPU utilization or memory utilization, and it will be all done automatically. So this is the concept of horizontal autoscaling and vertical autoscaling. And when we have a look at that in terms of Kubernetes, we actually have few more concepts. So let me explain it to you over here. We'll be doing the demo of one of these, which is HPA, but we'll be having an overall understanding of all the autoscaling features. So let's start with the scaling type. So we have, as discussed, we have two major scaling types. One is horizontal, another one is vertical. Horizontal auto scaling, also known as scale out or scale in. That means we are scaling out or we are scaling in. When there is a increased load on the server, we actually add more replicas. And when there is the decreased load on the server, we actually decrease the replicas to save the cost and to make sure we are using the optimum resources. In vertical auto scaling, however, we actually resize our machines or we actually resize our applications to meet the increased load. And whenever the demand is decreased, we actually scale it down. So there is this difference between scale out, scale in, or scale up and scale down. So it can be sometimes confusing, but if you associate it with horizontal and vertical, it will be easy to remember. Then in both of these, in horizontal auto scaling and vertical auto scaling, we do it on two different aspects, right? One is on the workload. It would be either on workload or it would be on infra, such as nodes. Workloads such as pods, infra such as nodes, and the same for vertical auto scaling as well. Let's take a few example of each one of those. Let's say we are using horizontal auto scaling on workloads. So the example that we saw, we have an application running. It has multiple pods. Whenever there is an increased demand on the server, whenever CPU utilization goes to, let's say, 60%, it will add more pods to the deployment, right? So that is your first part. And it is done by a process called HPA, Horizontal Pod Autoscaler. And this comes within, like it is built in Kubernetes, but it only takes metrics from the metrics server. So if you remember previous video, we installed a new pod or a new deployment called metrics server, and it is responsible for exposing those CPU, memory, and all other metrics to HPA. Right? But this HPA, it comes within Kubernetes. And instead of workloads or instead of pods, let's say we have to add more nodes to the server, more nodes to the infrastructure whenever there is an increased demand. So that is managed by a process called cluster autoscaler. And if we go to vertical autoscaling, same thing. If we have to do vertically autoscale our pods or workload, so we have to resize it with the bigger pods. For that, we use a process called VPA or vertical pod autoscaler. And if we have to, let's say, add more node pools to the server, to the cluster, we can do that with Node AutoProvisioning. So these features, most of them are not available. Like only HPA is available within Kubernetes by default, but rest like VPA, it's a separate project on GitHub. You have to separately install it and set it up. Cluster autoscaler, Node AutoProvisioning, this mostly comes with the cloud provider. So if you use a managed cloud service such as AKS, EKS, or GKE, then it comes with that. You cannot really add more nodes to your local infrastructure setup, to your local installation, like we are using Kind cluster or if you are using Minikube or anything else. So yeah, it comes with the cloud provider's managed service offering. So this is the overall difference between horizontal and vertical autoscaling. And there are some other autoscaling such as event-based autoscaling, because these horizontal and vertical, these works based on the metrics, your CPU, your memory, your disk, and so on. But there could be some cases where we have to, like in a production system, we actually have to autoscale our system, autoscale our infrastructure and our workloads based on certain events. Let's say there is an event whenever you are getting a lot of 502 error on one of the servers, or a lot of requests are getting rejected with a particular error code. So scale that node or add more nodes, add more pods, and so on. So this event based auto scaling can be done by a third party tool, which is again a CNCF project. It's called KEDA. And there'll be many more projects as well, but you can use any of those. This KEDA is one of the most popular tools that we use these days. And then we have cron or schedule based auto scaling as well, and so on. So out of all these, only HPA comes within Kubernetes installation. Rest, either you have to set it up manually from the binary, or it comes with a managed cloud offering such as AWS, GCP, or Azure. So this is the overall concept of scaling. Now we'll be doing a load test for the HPA, and I will show you how HPA actually works behind the scene. Okay, so as I was recording this video, I realized that CK exam lab version has been updated to 1.30. So I have upgraded my environment to 1.30. So if you do kubectl get nodes, now I'm using the latest version 1.30 as of June. Today is 3rd June. So this is what I'm using. Make sure you also upgrade your version, Kubernetes version, to 1.30. We have already discussed the installation steps in detail in one of those videos. You can refer that and maybe install a new version. It won't really make much of a difference when it comes to doing all the practice, hands-on, and everything, but it will be a good to have the same version as it will be there in the exam, and it is one of the latest stable versions, so it's good to use that. Now, to test HPA, first we need is a metric server. So if you remember, we have installed metric server as part of, I guess, in the previous video itself. So we can use the same YAML and install it. And it will be because we need metric server to expose the metrics to HPA, and HPA will get all the values of CPU and memory utilization from there, and it will take some actions based on that. So yeah, it is one of the prerequisites. I already have it running because I did not deleted it last time. So let's see, get pods -n kube system. Okay, here it is, metric server, it is running. So we are good with that prerequisite. Now let's create a deployment and a service on which we'll be doing the auto scaling. So I already have a YAML created in day 17 folder. Okay, so all the resources, it will be there in the GitHub repository. Don't worry about it. So it has two objects. One is deployment, one is service. Okay, till now we have not covered how we can use multiple objects in one single YAML. So we can do that with these three dash, which separates two different objects, right? So for example, here is our deployment and here it ends. And when the next object starts, like let's say this is a service, so we add one line in between with three hyphens, and that's it. That's how it knows that, okay, so the first object has been completed over here. From here it will be the second object, and you can have as many as resources created within one single YAML. So in this YAML, let's say we have a deployment. Deployment name is PHP Apache, and it's using an HPA example from the official K8 repository, right? This is one of the public repositories, and it has HPA example as the image. Now we'll be exposing this on container port 80, and we have specified request and limits. We have already seen that in previous video. So we are specifying that it should acquire 200 M of CPU. So M is like 200 M is similar to 0.2 of one CPU, right? And this is 0.5 of one CPU. So M is for milli. So it'll have 0.5 CPU and as the limit and 0.2 CPU as the request. And then we'll be creating a service which exposes this on port 80, right? And based on this selector, and this is the label that we have in the deployment. Okay, we have discussed this in depth already, so I'm not gonna spend much time on that. So now that we have our deployment ready, we can just apply this deploy.yaml, and it will create a deployment and a service. So let's see. Okay, so it has one pod because this deployment does not have replicas specified. That's why by default, it will create one replica of it. Okay, so we have one pod running and there would be a service running if we do get service. So PHP Apache, there is one service running on port 80 and it's been exposed now. Now the next is we have to create the HPA object. So you can use the imperative command and you can use the command. So I will show you how we can do that. So you use the command kubectl autoscale and deployment is what we need to autoscale. Then the name of the deployment, PHP Apache, and then we specify CPU percentage equal to 50. So this is the average CPU utilization that it looks for a given period of time, let's say, because the way it works is HPA keeps on monitoring your workload after every 15 seconds is the by default period, but you can configure it in controller manager. But for now, just understand that it will, after a few seconds, it will keep on monitoring your workload for the CPU utilization. So whenever for a brief period of time, let's say for 10-15 seconds, it will find that your average CPU utilization is going beyond 50%, then it will add more replicas to it. And we can specify min and max number of replicas. So min is 1, right? So that's mean when the node goes below 50%, then it will decrease the load. It will delete the additional replicas and it can go to minimum of 1 replica, which is the one that we have used as default. Okay, so we specify hyphen min equal to 1 and hyphen max equal to, let's say, 10. Okay, so we have, okay, it says already exists. So let me delete the already one. Delete VA. And the name was PHP Apache. Okay, let me create this again now. Okay, it says HPA auto scaled the deployment. So if we do get HPA, okay, now it is showing me, just drag it over here. Now it is showing CPU utilization as unknown because it takes few seconds to get the CPU utilization. 50 is the max that we set as the target. So as soon as it reaches to 50, add more replicas. Min pod is 1, max pod is 10. So if we run the command again, now it shows CPU utilization is 1% and 50 is the target for auto scaling, right? Now we have to actually simulate the load on this particular application, right? So we have to put some request on that so that it will increase the CPU utilization. So for that, what we can do is we can actually try generating the load, and we can do that. Okay, so the document that I was following was over here. See, so this was HPA. Okay, horizontal pod auto scaling, and if you go down, okay, I guess this one walkthrough example. Okay, so this is the command that we can use to increase the load on this server. Yeah, I've just made a copy of it so that I don't forget to paste that locally. So we can do that on a separate window so that we don't have to stop the application and it will be running in the background. So I have opened a separate terminal window, and this is the command that I'm going to use: kubectl run -itt load generator is a separate application that we are running as a container and is based on the busybox image. We are actually doing while sleep 0.001. So after every millisecond, it will try to get the request from this page, right? So it is just sending some random request to a page, a wget request to a page, and it will be just printing that, right? So it will increase some load on the server after a few seconds. So let's run that. Okay, and it is just printing the response. So I'm getting the response back as okay. So it is keep on printing that after every 1 millisecond. So after a while, if we check our application and if we do get HP again, we will see the load getting increased. So you have to wait for some time, and instead of running the command, you can actually add --watch so that it will only be changed once there is a change in the result. So now that we have seen the target is 160%, so this is the time it should add more pods. So let's see, get pods. Okay, it had added 5 more pods and this is still coming up. And if we do get HPA watch, so CPU utilization now to 37%, and it added 4 replicas already. Few of them were still coming up, so that's why it's not part of it. Now it has 5 replicas and it will keep on adding it as per the requirement, right? So if we do kubectl get pods, and if we want to check 1 2 3 4 5, right? So there are actually 5 pods running at the moment. And if we see the get HPA, the CPU utilization is 117%, which is more than 50%, and 5 or 7 replicas at the moment, right? Now it is showing 47%, but it will not be for a longer time, so that it will be captured as part of the HP action. So that's why it is not scaling it down. So let's see, it is still 7 replicas. So now what we can do is, yeah, we have seen the how HPA works, and with the help of an example, we did the load testing. So now let's Control C, let's interrupt this so that it will stop this container. Okay, it has stopped the container. It has stopped generating the load now. And let's go back. And if we do get pods, it will not be downsized instantly. It will take some time. But if you see key get HPA, so CPU utilization is now going down to 50%, and it will go down in some time. So it will take around a few minutes for this to go down to 0 or 1%. And then these replicas will also go down to a minimum of 1 pod, which is what we have specified. Yeah, so this was the example from HPA. And as I've mentioned, auto scaling is not part of CKA. So if you are just preparing for CKA, don't worry about it. But it is important to understand this concept: HPA, VPA, auto scaling in general, auto scaling in Kubernetes, and so on. So yeah, I hope this video was helpful. You would have understand everything about auto scaling. And I will see you tomorrow with the next video, or as long as the targets of comments and likes gets completed within the next 24 hours, you will see the next video. In the next video, we'll be looking into props, liveliness and readiness props. And yeah, that's all about it. If you like the video, give it a thumbs up and share it with your friends, family, and colleagues. Subscribe the channel if you are new here. Okay, thank you so much, and have a good day. Happy learning, and I will see you soon.